Every autumn, the world begins to change its colors. Forests that were green and full of life now glow with brilliant shades of gold, crimson, and amber. The air feels cooler. The days grow shorter, and everywhere around us, leaves begin to fall. It's one of nature's most familiar sights, but also one of its greatest mysteries. Why do trees shed their leaves when they seem most alive? Is it a sign of decay? Or could it be a stunning act of survival? As autumn arrives, trees begin to read the signs of change. They sense shorter days, colder nights, and the shifting angle of sunlight. To them, it's a signal that winter is coming. When temperatures drop and sunlight weakens, photosynthesis becomes inefficient. So the tree starts a remarkable process, slowing its metabolism, conserving energy, and preparing for months of dormancy. It's not death, it's strategy. Through spring and summer, every leaf is a masterpiece of natural engineering. It captures sunlight, absorbs carbon dioxide, and draws water from the soil, creating sugar to feed the tree. This is photosynthesis, driven by the green pigment chlorophyll. But chlorophyll needs constant light and warmth. When the days shorten, the tree begins to shut down its food factory. It pulls nutrients, nitrogen, magnesium, and phosphorus back from the leaves into its branches and roots for safekeeping. The green pigment fades, and the hidden colors begin to emerge. When chlorophyll fades, it reveals pigments that were there all along. Carotenoids give yellows and oranges, while anthocyanins produce reds and purples. Every tree species has its own unique palette, its chemical fingerprint. Maples turn fiery red, birches shine golden yellow, and oaks glow with deep bronze. But these colors are not just decoration. They play a role, shielding fragile cells from sunlight while nutrients are withdrawn. It's nature's final burst of brilliance before the quiet sleep of winter. Scientists have learned that this transformation can be described by simple physics and chemistry. The rate of color change depends on light intensity and temperature. Cooler nights accelerate chlorophyll breakdown, a process that follows a measurable pattern. In fact, the rate can be estimated by the inverse of temperature, meaning that as the temperature drops, the reaction speeds up. That's why early frosts bring sudden, intense color, while warm autumns stretch the season of gold a little longer. At the base of every leaf stem lies a tiny boundary, the abscission layer. Here, the tree seals off each leaf, cutting water and nutrients. The cells gradually weaken, and eventually the leaf detaches with the wind. What looks like a gentle fall is actually precise engineering. By releasing its leaves, the tree protects itself from dehydration and prevents snow and ice from weighing down its fragile branches. When a leaf touches the ground, its journey doesn't end, it begins again. Over weeks, it breaks down into minerals that enrich the soil. Those nutrients feed the roots of the same tree that once held the leaf. Autumn is not a time of death. It's renewal disguised as rest. So next time you watch a leaf drift through the air, remember, it's not falling in defeat. It's falling with purpose. Because in nature, even letting go is a sign of strength and renewal. What other hidden stories of science would you like to uncover next? Share your thoughts in the comments. And stay curious with Quick Why.